Magandang araw po. Ako po si Cristo Henrey mula po sa ME2B. At ako po ay nasa grupo ng binubong miyembro ng 2B at 2C. Kami po ang grupong ME Youth.
Magandang araw po sa inyo lahat. Ako po si Aerol sa Bautista from ME2B. At ako po ay kabilang sa grupo ng ME Youth.
Ako po si Patricia, Sahlee or Panganiban from BSME 2C. Ako po ay kabilang din sa grupo ng ME Youth. So our topic for today is falling bodies and air resistance. First, what is the connection between falling bodies and air resistance? As an object falls through air, it usually encounters some degree of air. Air resistance is the result of collisions of the object's leading surface with air molecule. The actual amount of air resistance encountered by the object is dependent upon a variety of factors. So if we take on this circumstance, the positive direction to be oriented downward, then the net force acting on mass is given by F is equals to F sub 1 plus F sub 2. F will be mg minus kv, wherein weight F of 1 is equals to mg of the body is force acting in the positive direction, and air resistance F sub 2 is equals to negative kV is a force called viscous damping acting on the opposite direction. So in physics, para makuha natin yung force, we need to multiply mass and acceleration. But to get the acceleration, we need to find also the final velocity and initial velocity, and also the time. So in this formula, makikita natin na may relation yung acceleration and velocity. So meaning, yung A is gagawin nating V with respect to T, kaya naging dV over dt. So here, pinalitan lang natin yung value ng A, which is dV over dt. So, babalik tayo ngayon dito sa nakuha natin kanina, na ang force is equals to mg minus kv. Ito na yung dalawang force na value niya. So, yung force na to ay ipapalitan natin ng itong formula. Kaya ang mangyayari, m dv over dt is equals to mg minus kv. Kaya ito ngayon yung magiging first derivative natin. So here, K is the positive constant of proportionality. So if S with respect to T is the distance the body falls in time T from its initial point of release, then V is equals to ds over dt. And acceleration will be dv over dt. Kukunin natin ngayon yung second derivative niya is A is equals to second derivative S over dt squared. So ngayon, since ito yung first order natin, which is m multiplied to dv over dt is equals to mass times gravity minus k times velocity. Kukunin ngayon natin yung second derivative or yung second order niya, which is with respect to t, s with respect to t. Kaya magiging m second derivative of s and dt squared equals mg minus k. Yung v natin magiging ds over dt. Papalitan lang natin, and ayun na, ito na yung last equation na natin. For some object, the air resistance is proportional to the square of the velocity, like in this example. So push an object we have the differential equation dv over dt is equals to g minus k v squared. The rate of change of velocity is gravity minus something proportional to the velocity squared. And that's it.
So, our topic is falling object and air resistance, an application of first order differential equation. So, nilinawin ko lang din yung ibang parts ng aking diniscuss. So, yun nga, yung dalawa, yung F sub 1 and F sub 2, ito yung two forces acting on the object, which is the force due to gravity and the air resistance. So, ang ginamit nating formula niyan ay F is equals to mg minus kv. Ito ang net force natin. So, since ito, naipaliwanag ko naman na din kung bakit positive yung downward direction, tapos negative naman yung upward. Kaya yung air resistance ngayon ay nagiging negative siya. So, yun, sa paggamit natin ng Newton's second law of motion, which is the FMA, may relation yung acceleration and yung velocity. Kaya ngayon, papalitan natin yung acceleration ng dv over dt. Kaya, naging F is equals to m times dv over dt. So, since yung nakuha nating formula kanina sa net force is equals to mg minus kv, ipapalit ngayon natin yung formula ng force ngayon dito sa Newton's second law para makuha itong mismong formula natin na mg minus kv is equals to m dv over dt. Ito na ngayon yung na-discuss ko ngayon. So, i-simplify lang din natin lalo. So, ang ipa-plus lang natin ngayon, both sides ay positive kV. So, yan na ngayon siya. M times dV over dt plus kV is equals to mg. This is a linear first order differential equation. Kaya, isi-simplify lang natin siya sa kanyang standard form, which is dV over dt plus k over m. V is equals to G. As you can see, we divided both sides by M. Kaya nakuha natin yung isang formula. Take note, this will work when air resistance is proportional to velocity. So, our example here is a steel ball weighing 1 pound is dropped from 2,500 feet with no velocity. As it falls, air resistance is equal to V over 8 in pounds, where V is the velocity in feet per second. Find the limiting velocity and the time it takes for the ball to hit the ground. So, ito ang gagamitin nating formula, dV over dt plus k over m, V is equals to G. Siyempre, kukunin natin yung mga nawawalang value, which is yung G. Ang acceleration due to gravity, which is equals to 32 feet per seconds. Since we are dealing with feet, kaya gagamitin natin ngayon is in feet per seconds. Acceleration due to gravity. Our K now will be 1 over 8 from the given natin na V over 8. So, makukuha na natin ngayon yung value ng mass gamit yung formula ng weight is equals to M times G. Since we have the given weight, which is 1 pounds. So, we have now the value of G, the K, and the M. So, just substitute the value. So, simplify, and we will get the answer dV over dt plus 4V is equals to 32. Since this is a linear first differential order, we are going to solve this using integrating factor. So now, integrating factor is equals to E integral to 4D. Our integrating factor now will be E raised to 4T. And we are going to multiply our integrating factor in all terms. And this will be equal to d over dt times the left sides is the product of the is always the equal to the derivative of the product of the integrating factor and our function v. So 32, i-integrate lang din natin yung both sides. Makukuha natin ngayon. Since meron tayong e raised to 4 sa right side, ngayon, i-derive lang natin siya. Makakuha natin is, meron tayong common, may factor ngayon tayo na 1/4. Kaya, i-divide yung 32 sa 1/4. So, isi-simplify lang din natin. Para makuha dito ngayon yung change in velocity, kailangan na nating i-divide both sides by e raised to 4t. So, our change in velocity will be 8 plus c e raised to negative 4t. So, since our initial velocity is 0, so 8 plus c will be equal to 0. To get the value of c, i-transpose lang natin yung 8. So, it will be equal to negative 8. So, substitute the value of c. V with respect to t will be equal to 8 minus 8 times e raised to negative 4t. So, now to get the limiting velocity, yan, gagamitin lang natin yung limit na yan. So, makukuha ngayon natin is 8 feet per second. Our limiting velocity will be 8 feet per second. So, in terms sa position nung ball, kumbaga saan mapupunta yung ball, i-integrate ulit natin siya with respect naman sa position with s with respect to t. So, integrate na natin ngayon yung value ng ating change in velocity. Since ang u natin ay negative 40, magkakaroon ngayon tayo ng negative 1/4. So, yun yung i-multiply natin dito. Ngayon, makukuha na natin yung position ng ball and makukuha na din natin yung time na makukonsume ng bola ng object para bago siya sa mismong ground, to hit the ground. So, since 0 din naman yung initial point nito, isi-0 lang din natin siya. Tapos, makukuha natin ngayon, which is 2 plus c. Para makuha na rin natin yung value ng constant, i-substitute lang natin yung 2. So, magiging negative 2. And, substitute lang din ulit natin yung nakuha nating c dito sa mismong formula ng s with respect to t is equals to 8 plus t. 8 times t plus 2 e raised to negative 4t and the value of our constant which is negative 2. So, eto, makakuha din natin to in the graph. Makakuha natin yung mismong time that takes the ball to hit the ground, which is equals to 312.75 seconds for the object to hit the ground. And that's all.